Welcome to the rebuild of the live diesel. This loco is built to 1/12 scale to run on 45mm gauge track. It's based on Dave Watkins's detritus plans and scaled up. I am converting the loco to electric starting using a cordless drill bought for the purpose. A 14mm socket is used to drive the OS engine one-way clutch. I bought some new old stock parts from the US in case I fouled anything up. A clutch and starting shaft. Apparently the engine is rare and valuable, so I need to be able to return it to its original spec if need be. Here's the socket and 3/8 driving shaft, turned from 3/8 square brass bar. A nice 4-jaw chuck turning project, clocking up the flats so that it runs true in the drill chuck. The new cordless drill with socket mounted, ready to go. Because the engine crankshaft centerline is level with the top of the frames, I need to cut out a section of the footplate and make a cutout in the buffer beam for the starter. Here I am truing up the top face of the front coupler to accept a fill-in piece for the footplate. Footplate and buffer beam cutouts to fit the starter. I'm going to have to remove the coupling each time I start the engine. The footplate is off again to drill some holding down screw holes near the cutout. I've clamped it to a block in the vise for center punching. Here's the center punch. I scribed the lines in the paintwork using the digital calipers. It had to be accurate. I drilled it afterwards for 8BA hex head screws. The bonnet covers these when in place. I've got it all lined up ready for spotting through with a new cordless drill. Spotted through into the frame extension pieces. Afterwards I unscrewed the buffer beam assembly and drilled them 1.8mm to depth in the bench drill, then tapped them 8BA. The footplate is now screwed down at the front for rigidity. Brass countersunk screws. I didn't have any steel countersunk 8BA screws on hand. Ready for painting. The tin plate fuel tanks that I originally made. The top one was used on the loco. These are trials in tin plate soldering with the 80-watt soldering iron. It solders so easily, and I didn't even need to remove the paint. Just scratched away with a hot loaded iron and the paint is gone. Very satisfying. Starting on the all copper fuel tank, using the same 0.9mm sheet that the Corey Hunslet saddle tank is made from. The tank needs a cutout to clear the starter. Sawing a strip off with the Eclipse 55 sheet metal saw. Filing to the line, 1/3 at a time, and then finishing off with the file lengthways. The tank needs to be 63mm wide, including 0.9mm end plates, so this strip will be 61.2mm, or thereabouts. Partially bent after annealing. I'm just filing the first bent length to get the correct dimension, using a piece of 1/2" tool steel as a filing guide. Here's the tank shell silver brazed for security, wired tight for subsequent brazing of the first end plate. The dimensions should be 38mm high, 40mm wide and 61.2mm long. End plate brazed on and filed to size afterwards. The flux and braze were applied internally, snippets of silver braze, then heated vertically, placed on a refractory paper. 3 out of 4 pieces melted and flowed nicely. One didn't and cut my finger. I sealed it later with soft solder. That's a tank, not my finger. This hole is for a small fuel pickup sump, so I can really drain the tank. It was hole sawed using a 14mm diameter saw for domestic 1/2" copper pipe. Here it is turned to fit the hole, 0.2 inches long, sitting on a piece of 0.9mm sheet, on a piece of refractory paper, so the fire brick doesn't sink all the heat. Well on the way to melting the snippet of silver braze. The flux is liquid, coating the joint. I push the snippet into the correct place with a piece of wire before this shot. The braze has melted and been sucked into the joint and out the other side. Filing the large cutout for the starter. This took a lot of time, but it was enjoyably spent listening to a Joseph Sheridan Le Fanu audiobook. I had to open out the cutout, originally sized for 3/4 inch water pipe. I used a piece of the pipe sawn down the middle, annealed, then opened out and slid onto the original pipe. This was then soft soldered in place and then sawn and filed down to the top surface. The soft soldering was all done internally with the 80-watt iron, zinc chloride flux and plumber's solder. Solder was applied to the half tube too, and then both pieces sweated together using the Sievert blowtorch. Here's the tank and second end plate soldered up, ready for sweating together with the butane blowtorch. Prior to this, the hole for the fuel pipe that the engine draws from was drilled and the tube soldered in place. It's a bent tube salvaged from the original tank. The sump hadn't been soldered yet. Leak testing the tank in the wash basin. The fuel pipe and sump are soldered using electrical solder. This is a lower melting temperature. I wrapped the solder around the parts, applied zinc chloride flux and heated gently with a butane blowtorch. No leaks were detected by me blowing into the silicone tube. The underside of the tank showing the sump and the overflow tube, the top of which goes right to the top of the tank and is beveled. This is K&S 1/8 inch copper tube. The top of the tank showing the filler tube on the left and the engine feed tube on the right. These are K&S 1/8 inch brass tube. A solid K&S 1/8 inch brass post has been added to hold the tank in position, as shown in the next image. The tank is held by these two silicone tubes. Ready for starting. Thanks for watching.